Assalamualaikum and good day to everyone. Today I will talk about polyaniline-Chitosan composite electrode for electrochemical detection of CIP. In other words, I will explain about developed sensor to detect antibiotic, which is CIP. Before I begin, let me introduce myself. My name is Nur Ilya Natasha binti Muhammad Sabri under the supervision of Dr. Kaviraja Pandian, anak lelaki Sabah Sevam. Let us begin with the introduction part. So, what is CIP? CIP is a second generation fluoroquinolone antibiotic, and it is said that more than 75% of CIP is excreted unchanged, means it can leave the body without being metabolized and allowing the active CIP to enter the wastewater system. This can lead to antimicrobial resistance and toxicity to aquatic ecosystem, thus disrupt the ecological balance. Due to its widespread use of CIP, this antibiotic become the most frequent antibiotic detection in environmental water. However, conventional wastewater treatment is inefficient to remove completely the CIP residue, while the existing analytical techniques such as HPLC or LCMS require expensive instrumentation, time-consuming sample preparation, and sophisticated laboratory equipment. However, in contrast, electrochemical sensor offer several advantages, including rapid response, low cost, simple operation, and portability. The sensing material used in this study are penny and chitosan. Penny and chitosan are chosen for several reasons. One, penny have high electrical conductivity, fast electron transfer, signal amplification, and large electroactive surface area, while chitosan is excellent film forming ability, good mechanical stability, high mechanical capability, biocompatible, and environmentally friendly. Chitosan also have abundant amino and hydroxyl functional group that will enhance the absorption of CIP on the sensor. Moving on to the application of the sensor in daily life, there are several potential areas where it can be applied. First, it can be used for wastewater monitoring to detect CIP contamination before the wastewater is released into the environment. Second, it can support drinking water quality monitoring by providing rapid screening for antibiotic residue. It also has potential application in the pharmaceutical industry, particularly for monitoring antibiotic-related waste. In addition, it can be used for environmental monitoring of water sources such as rivers and lakes. Lastly, by enabling early detection of CIP contamination, this technology can contribute to public health protection by reducing exposure to antibiotic residues. Therefore, this sensor has potential as a simple and rapid tool for monitoring CIP in real-life application. The experimental procedure begins with the penny synthesis, where aniline monomer is added into hydrochloric acid before addition of APS. Lastly, the precipitate was collected and dried. The chitosan solution is prepared by adding chitosan powder in 2% of acetic acid. The penny chitosan composite was prepared by chemical oxidative polymerization, where 100 ml of 1 mHCl was put in a beaker, then aniline monomer was added drop by drop while stir using a magnetic stirrer for 1 hour. The chitosan solution was added and continued to stir for another 2 hours. Then the APS solution was added drop by drop while stirred in an ice bath for 24 hours. Finally, the solution was centrifuged and washed repeatedly and dried for 24 hours in 60 to 70 degrees Celsius before collected the precipitate. For the benefit of this study, there are three main aspects, which are environmental protection, public health, and water quality monitoring. First, in terms of environmental protection, the sensor can help with the early detection of CIP pollution in water. By detecting the antibiotic at an early stage, it can help prevent its accumulation in rivers and lakes, therefore supporting a healthier aquatic ecosystem. Second, for public health, early detection of CIP can contribute to cleaner and safer water resources. It can also help reduce human exposure to antibiotic residue and indirectly support effort to combat antimicrobial resistance or AMR. Lastly, for water quality monitoring, this sensor has potential for routine monitoring of wastewater and surface water. It provides rapid screening, which can help identify potentially contaminated area before further laboratory confirmation is carried out. Overall, the study highlights the potential of electrochemical sensing as a rapid approach for monitoring CIP contamination. For the conclusion part, CIP pollution require continuous monitoring because even low level of antibiotic residue can pose environmental and public health concern. Electrochemical sensor provide a rapid and practical approach for early detection. Therefore, early detection can help prevent water contamination and ultimately contribute to a healthier environment and society. That's all from me. Thank you for listening and watching. See you again.